one more video of practice problems. Unit 3, Lesson 13 this time. All right, in Lesson 13, we're talking a lot more about multiplying complex numbers. So we're going to be doing some of this by hand, and again, some of it using Desmos, some of it using our calculator. Please be familiar with all of those. I want you to use those resources, okay, especially to check your work. So when we think about which expression is equivalent to 2i times, and now we're in parentheses, 5 plus 3i, one of the things I want to start off by thinking is the same kind of idea of distributive property. So I need to multiply this 2i times 5 and 2i times 3i. Now, you can set up a grid to use this. So if you like multiplying with the grid, go for it. We have 2i is one thing being multiplied. It's being multiplied with two different things here. So I'm going to put that in two different things. It's being multiplied with 5. And it's being multiplied with 3i. So I want to make sure I'm multiplying those two different things. So when I multiply 2i times 5, 2 times 5 is 10. And there is an I there, so I'm going to keep that I going on there. Okay, that's our 10i. And I'm going to do my other multiplication. 2i times positive 3i. Positive 2 times positive 3 is a positive 6. And then I times I is I squared. Now, none of my answers have a squared in it, because you should hopefully know by now pretty regularly. Anytime we see I squared, it equals -1. Okay, I think we've shown that enough times, and we'll just show it one more time. I is the square root of -1. And if I'm going to square something that is a square root, those two things cancel each other out, and all we're left with is a -1. So this isn't really a positive 6 times I squared. It's a positive 6 times a -1, which is a -6. So my last thinking before I get to my final answer is that this part is now real. So it's going to go first. So there's that -6 that's first. This is the only one that has a -6 as the real part. So -6 plus 10i is my final answer, because this part is imaginary. All right. Number 2 says, Lynn says when you add or multiply two complex numbers, you will always get an answer that you can write in a plus bi form. Noah says, I don't think so. Here are two exceptions I found. And he adds 7 and 3 and gets 10, and 2i minus 2i and gets nothing, right? Those two cancel out. So he has a 0i. Here he's doing some multiplication. Okay, so multiplying 2 plus 2i times 2 plus 2i, and he's getting 8i. So checking Noah's arithmetic, he is very much correct. Yes. Both are correct. And then it says, can Noah's answers be written in the form of a plus bi, where a and b are real numbers? I'm going to say yes. Here's the thing. We just did it in our last set of practice problems, but I also just did it right up here. 10 is the same as 10 plus 0i. If I don't have an imaginary part, I can put 0 there. And 0 is a real number. It's real. We can say I have 0 somethings. I can show you nothing, right? And then our 8i, well, 8i is the same as 0 plus 8i. I don't have a real part. It's only imaginary. So yes, I can write anything that is being added complex or multiplied complex as a complex answer. I just have 0 as a placeholder. That's all. So if someone missed class, how would you write this in the form a plus bi, where a and b are real numbers? So this is some multiplication. If somebody missed our class, I would tell them, first of all, to go watch the video. But then I would tell them to go back to what we were doing up here, that we can use the grid to multiply the same way that we used the grid to multiply 2 factors or 3 factors or 4 factors way back in Unit 2 with the polynomials. So I'm multiplying 3 minus 5i and I want to multiply that with negative 2 plus 4i. So I'm setting up one factor down the side. Remember, take that whole factor. If it's in parentheses together, it has to be down the same side together. The other factor across the top. And now I'm going to multiply to fill the boxes. Multiply, multiply, multiply to fill. Positive 3 times a negative 2 is a negative 6. Negative 5 times a negative 2. Negative times negative is a positive. 5 times 2 is 10. And there is an I there, so I have to keep an I in my answer. Now I'm going to ignore this column and work on multiplying these two things. So 3 times a positive 4i. Positive 3 times positive 4 is a positive 12. And there is one I up there, so I need to keep one I here in the box after I multiply. Negative 5 times a positive 4 is a negative 20. I times I, well, now I have two i's, so I have I squared. And just like up on top, I squared is negative 1, and negative 20 times negative 1 equals a positive 20. Now I'm almost done. I have to write it in a plus bi form. So I'm going to think about my real parts first. I have a negative 6 and a positive 20. When I do negative 6 plus positive 20, I get a positive 14. So that's how I'm going to start. My real number is 14. My imaginary numbers are here on the diagonals, just like we saw them before. Okay, so I have 12 i's and I have 10 more i's. So 10 i's plus 12 more i's is 22i. There is my imaginary part and my final answer. So I'd explain to them that we're going to use the grid, multiply to fill the boxes. This is the only extra step right here. I squared is a negative 1. So that way we only have real parts and imaginary parts. Our answer is never going to have an I squared in it because I squared is negative 1. We can turn it to a very real number. Double check. I'm just typing in the original to make sure I've got it. Good to go. Which expression in number 4 is equal to 729 to the 2/3 power? Okay, this is back to lesson 4, so I'm going to go a little bit faster. I'm actually going to just use my calculator for this. Just remember that I'm going to put any fraction in parentheses. So just typing this in, 81. Definitely not equal to 243 or 486, but 9 squared equals 81, so that looks good. 27 to the 3rd is definitely not 81. This is just to remind us that we can take any denominator like that and put it on the little notch and do 729, the cube root of 729, and then square it. And your nifty perfect cubes chart will tell you that that is 9 squared. Or your math button will also let you do cube roots. Number 5, find the solution or solutions to each equation, or explain why there is no solution. Okay, I'm going to pull out my nifty chart again. I love using this thing. It helps me just always think about how many answers I'm looking for. So I have 2x squared minus 2/3 equals 5 1/3. I need to think about this. I need to get that by itself first. I have x, I'm squaring it, I'm multiplying it by 2, then I'm subtracting 2/3. So opposite order means that I'm going to now add the 2/3 to both sides of my equal sign. 2x squared equals, those cancel, 5 1/3 plus 2/3 more, well, that makes a whole nother complete 1. So 5 plus 1 is 6. Okay, so now I have x, then I'm squaring it, multiplying it by 2 to get 6. So to undo that, I have to now divide by 2. All this work to just get to this part to answer this question. If I have something squared and it equals a positive number, I'm going to have 2 real solutions. 2 real solutions. That's all it asked me to do. It didn't actually ask me to find them. Oh, wait, it does. Find the solutions. Okay, well, there's 2 of them, so let's find them. Sorry. We're going to just square root. And to find both of those real solutions, x is going to be the positive square root of 3 or the negative square root of 3. Remember, if we have a square root and we choose to square root it, we're going to find 2 answers. Here is something squared equaling a positive number, 2 real solutions. So I'm not done until I can have 2 real numbers here. X equals, X equals. I start with x, I add 1 to it, then I square it to equal 81. Opposite operation, take 81, square root it. We're going to do it backwards, right? Opposite PEMDAS. X plus 1, square root cancels the squared, but what's inside the parentheses stays intact. X plus 1 equals positive 9, or x plus 1 could equal negative 9. 2 answers, 1 positive, 1 negative. Last but not least, I have to deal with this plus 1. That means I need to subtract 1 from everywhere, both sides of both sets. X equals 9 minus 1, which is 8. X equals negative 9 minus 1 more, which is negative 10. So my answers are 8 and negative 10 for this one. Again, if you're asking yourself, hey, how can I check this? Desmos. The answer is always Desmos. Check it. All right. And last but not least, I got a little bit of everything going on here. I got to get that by itself. I have x, then I'm going to square it, times it by 3, add 14 to equal 12. Oh gosh, I just wrote all that and you can't even see it. X, square it, times it by 3, add 14 to equal 12. Let's do all of this backwards. 12 minus 14. So this just tells me what I'm going to do backwards, what I'm going to deal with first. I'm going to deal with that plus 14 by subtracting 14 from both sides. 3x squared equals negative 2. Wait a second. My paper that I just dropped on the floor says that if I have something squared equaling a negative number, I'm going to have no real solutions. There's still solutions. They're just not real. So I'm going to keep on solving this. Okay? No real solutions, but 2 perfectly good imaginary solutions. The only time that we have no solution at all is if I have a positive square root equaling a negative number. So let's keep on solving this thing. I dealt with that 14. Now I got to deal with this timesing by 3. We're going to divide it by 3. And now we're going to take, we've dealt with that. Now I need to deal with the square root. With the squared, I mean. So you got to get rid of the squared by doing a square root. Now we're going to have imaginary solutions. So x is going to equal I square root of 2/3. And x is going to equal negative I square root 2/3. Two non-real solutions. But still 2 solutions. And I found them. All right, plotting each number on a complex plane. Remember, this is just thinking about our real and our imaginary. Five I is there. I did that one in green. Maybe you want to change colors too. 2 real, 4 positive imaginaries. Here is part B in blue. I'm going to do part C in hot pink. Negative 3. That's a very real number. There's no imaginary part. Oh, I already used green. Let's use red. 1 positive, 3 negative I's. There's part D. And last but not least, E starts off with negative 5 going to here and down 2I. E. Alrighty, we need all the expressions that are equivalent to this. Ugh. It's trying to get us to remember. The same thing we were doing with the positive or with complex numbers to multiply, we have done in the past with x's. I kind of like that they asked us this here. That's kind of cool because it's the same thing. So 3x times x is 3x squared. 2 times x is a positive 2x. 3 times a negative 4 is a negative 12x. 2 times a negative 4. Remember, every single one of these I'm multiplying. So multiply, 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 multiply to fill all 4 boxes. That's a negative 8. So everything I should be looking at should be something that will get us equal to 3x squared minus 10x minus 8. I combine these two together and get that minus 10x. Okay. So this is definitely not equal to that. This is an exact match. There's the 3x, but 3 times 2 is 6, not negative 10, so that's not right. Wow, they want me to do all kinds of math here. 3x squared minus 9x minus 1 more x, that's a negative 10, minus 8. Remember, this distributes to both of them. This is also equivalent. Well, they made it look pretty different, didn't they? Okay, let's look at these ones. Keep on going. 3x squared minus 9x minus 10x. Wait a second, that's 19x. I'm not even going to keep on going with that. Sorry. And last but not least, 3x squared minus 12x plus 2x. Okay, that's still in the running because these equal negative 10x. Minus 8, we have a third one. So B, D, and F are equivalent. We made it. All done.